Please, sir, do not interrupt my chain of thought. I'm a busy Martian. I'm just about to solve the Earth's fuel problem.
You are? Solve our fuel problem? Ooh, how neighborly. If it's not a trade secret, how are you gonna do it?
I'm going to blow it up.
Don't tell me you haven't noticed that low criminal forehead.
Being disintegrated makes me very angry. Very angry indeed. Oh dear, now I suppose I shall have to use force. That wasn't a bit nice. You have made me very angry. Very angry indeed. Oh, mutiny makes me so angry. I'm not angry, just terribly, terribly hurt. I think man is the most interesting insect on Earth, don't you? There is a growing tendency to think of man as a rational thinking being, which is absurd.
Let's embark on this journey, tracing the steps from the very beginning to the formation of stars and eventually, the dynamics of photon plasma. 1. The origin of reality, the Big Bang. Our current understanding of the universe's origin points to the Big Bang, a singularity from which space, time, and matter expanded. We need to consider the conditions immediately after the Big Bang: extreme temperature, density, and energy. This initial period saw the emergence of fundamental particles and forces. Inflation, cosmic inflation, a period of rapid expansion, smoothed out the universe and set the stage for later structure formation. Understanding inflation can help us grasp the initial distribution of matter and energy. 2. Formation of stellar mass, particle physics. After the Big Bang, quarks and leptons formed, eventually combining to create protons and neutrons. The early universe was a hot plasma of these particles. As the universe expanded and cooled, these particles began to coalesce. Dark matter, though not fully understood, played a crucial role in the formation of structures. Its gravitational influence caused ordinary matter to clump together, forming their seeds of galaxies and stars. The cosmic web, the distribution of dark matter and ordinary matter formed a cosmic web of filaments and voids. These filaments became the birthplaces of galaxies. 3. Formation of stars, gravitational collapse. Within the cosmic web, dense clouds of gas and dust began to collapse under their own gravity. This collapse increased the temperature and pressure at the core of these clouds. Protostars, the collapsing clouds formed protostars, which continued to accrete matter from their surroundings. As the core of the protostar became denser and hotter, nuclear fusion began. Nuclear fusion, the fusion of hydrogen into helium, released immense amounts of energy, creating the outward pressure that balanced the inward pull of gravity. This marked the birth of a star. Stellar evolution. Stars evolve over time, depending on their mass. Massive stars burn hot and fast, while smaller stars burn slowly and live longer. 4. Dynamics of photon plasma. Stellar cores. The cores of stars are composed of photon plasma, a state of matter where atoms are ionized and photons are abundant. The intense heat and pressure in stellar cores create the conditions for nuclear fusion. Photon pressure. Photons exert pressure, which plays a crucial role in balancing the gravitational forces within a star. Understanding photon pressure is essential for controlling the photon plasma in our Dyson sphere generator. Magnetic fields. Stars generate powerful magnetic fields, which play a significant role in plasma confinement and activity. We can learn from stellar magnetic fields to design our electromagnetic containment system. Plasma instabilities. Stellar plasmas can exhibit instabilities, such as flares and coronal mass ejections. Understanding these instabilities is crucial for preventing disruptions in our generator. Solar photon plasma energy. 1. Nuclear fusion process. The primary fusion process in the Sun is the proton-proton chain reaction. In this series of reactions, 2 protons fuse to create deuterium, a hydrogen isotope, releasing a positron and a neutrino. A proton then fuses with deuterium to form helium-3, releasing a gamma-ray photon. 2 helium-3 nuclei can further fuse to create helium-4, releasing 2 protons in the process. The energy released in these reactions comes in various forms, including kinetic energy of the particles and electromagnetic radiation, photons. 2. Energy transport mechanisms. Radiative zone. Outside the core, energy travels outward through a radiative zone, where photons are repeatedly absorbed and re-emitted by particles. This diffusion process is slow, taking millions of years for energy to reach the surface. Convective zone. Above the radiative zone, in the convective zone, energy is transported through convection currents. Hot plasma rises toward the surface, cools, and then sinks back down, creating a cycle that effectively transports energy to the outer layers. 3. Photon gas and pressure. The high-energy photons generated in the core contribute to the photon gas that fills the star. This gas exerts pressure outward, which is crucial for balancing the inward pull of gravity. The balance between this radiation pressure and gravitational forces allows the star to achieve stable conditions over billions of years. Solar electromagnetic fields. 1. Generation of magnetic fields. The solar magnetic field is generated by the movement of conductive plasma within the Sun, primarily in a convective zone. This dynamo effect arises from the combination of rotation and turbulence in their plasma, creating complex magnetic field structures. The Sun's rotation, differential rotation, causes the equator to rotate faster than the poles, leading to twisting and stretching of magnetic field lines. 2. Magnetic field dynamics. Magnetic field lines can become twisted and concentrated, leading to regions of intense magnetic activity, such as sunspots. These are cooler areas on the Sun's surface where the magnetic field is particularly strong. Solar flares and coronal mass ejections, CMEs, occur when magnetic field lines become unstable, releasing huge amounts of energy and charged particles into space. 3. Impact on solar wind. The solar magnetic field also plays a role in shaping the solar wind, a stream of charged particles emitted from the Sun. The magnetic field can trap and channel these particles, influencing their direction and intensity as they travel through the solar system. The interaction between the solar wind and the Earth's magnetic field leads to phenomena such as the auroras. 4. Magnetosphere and cosmic interactions. The Earth's magnetosphere, generated by its own magnetic field, interacts with the solar wind and helps protect the planet from harmful cosmic radiation. This interaction is crucial for maintaining conditions suitable for life on Earth. The interplay between solar photon plasma energy and electromagnetic fields is fundamental to the life cycle of stars. This dynamic relationship not only governs the processes within the star but also affects its interaction within the surrounding stellar space and other celestial bodies. 1. Solar photon plasma energy generation within stellar objects. In stars, including our Sun, nuclear fusion occurs in the core. This process primarily involves the fusion of hydrogen nuclei, protons, to form helium nuclei. During this fusion, a significant amount of energy is released in the form of photons, which are particles of light. The core of a star is characterized by extremely high temperatures, millions of degrees Celsius, and pressures, which facilitate these fusion reactions. The energy generated from these reactions causes the release of photons, creating a hot, dense plasma composed of ions and free electrons. Conversion to fuel component. The energy produced from nuclear fusion creates outgoing radiation pressure, which counteracts the gravitational forces trying to collapse their star. This balance between gravitational pressure and radiation pressure is known as hydrostatic equilibrium. As photons are produced, they are absorbed and re-emitted by particles in the plasma, causing them to scatter and take a long time, thousands to millions of years, to escape from the core to the surface of the star. This process generates a photon gas that contributes to the star's overall energy output. 2. Solar electromagnetic field dynamics and function. The Sun has a complex magnetic field generated by the movement of charged plasma within its interior. This movement is influenced by the convection currents and the rotation of the Sun, which contribute to the dynamo effect, producing the solar magnetic field. The electromagnetic fields play a crucial role in confining and controlling the behavior of the photon plasma energy. The charged particles in the plasma interact with the magnetic field, which helps to keep the plasma bound to the star. Confinement of photon plasma energy. The electromagnetic fields create a sort of magnetic cage that helps prevent the charged particles in the plasma from escaping into space. This confinement is essential for maintaining the stability of the star and allowing it to continue its fusion processes. Additionally, these magnetic fields can influence solar phenomena such as sunspots, solar flares, and coronal mass ejections, which are all manifestations of the dynamic interactions between the solar plasma and its magnetic field. In summary, solar photon plasma energy is generated through nuclear fusion in the star's core and is kept bound by the solar electromagnetic fields, which help stabilize the plasma and maintain the energy output necessary for the star's life cycle. This concept is the core principle of the Dyson sphere's dynamic power generator, emulating this process in a microcosmic environment using synthetically generated processes. The problem we must address next, now that we have the principles of photon plasma energy generation that can be applied to the Dyson sphere outline, will be how to contain the plasma core and the radiation emissions for a clean fuel source that is safe to use. Notations of the outline adaptation. This concept will outline the principal dynamics of the power core of the Dyson sphere. The next level surrounding the core will be the differential rotation of their outer core shell. One will produce the kinetic energy from the friction of the differential rotation, the other will create the photon gamma wave emissions that must remain contained within the outer core region of the sphere. I see this gamma wave emission as a component necessary to maintain an equilibrium of balance in the dynamic process of photon energy fusion and not a factor that can be collected for energy distribution as a resource byproduct. But I shall reserve the dynamic outline until I have more research to fuel my inspiration. Connecting to the Dyson sphere generator, electromagnetic containment. By understanding how stars confine their photon plasma, we can design more effective electromagnetic containment systems. We can draw inspiration from stellar magnetic field configurations and plasma control mechanisms. Energy generation. By studying stellar fusion processes, we can optimize the fusion reactions in our generator. We can explore alternative fusion fuels and reaction pathways. Energy extraction. By understanding how stars radiate energy, we can design more efficient energy capture mechanisms. We can explore new ways of capturing photons, X-rays, and gravitational waves. This journey through the origins of reality and stellar evolution provides a strong foundation for our research. By grounding our work in fundamental principles, we can avoid the pitfalls of infinities and ensure that our Dyson sphere generator is based on sound scientific understanding. You're absolutely right. Recent advancements in solar observation technology, particularly with advanced satellites, are providing us with an unprecedented level of detail about the Sun's solar dynamics. This data is invaluable for our understanding of photon plasma and for designing the core of our Dyson sphere generator. Here's how these observations are benefiting our research. 1. High-resolution imaging and spectroscopy. Satellites equipped with advanced telescopes and spectrometers can capture high-resolution images and spectral data of the Sun's surface and atmosphere. This allows us to study the fine details of solar features, such as solar flares, coronal mass ejections, CMEs, sunspots, granulation. These observations provide crucial insights into the dynamics of photon plasma and the processes that drive solar activity. 2. Magnetic field mapping. Satellites can measure the Sun's magnetic field with high precision. This allows us to map the complex magnetic field structures that control plasma flow and energy release. Study the processes that generate and maintain the Sun's magnetic field. Gain a deeper understanding of magnetic reconnection, a key process in solar flares and CMEs. 3. Plasma diagnostics. Spectroscopic observations provide information about the temperature, density, and velocity of the solar plasma. This allows us to Study the properties of photon plasma in different regions of the sun. Track the flow of plasma and energy through the solar atmosphere. Investigate the processes that heat and accelerate the solar wind. 4. Gravitational wave studies. While directly observing gravitational waves from the sun is difficult, the study of the sun's internal dynamics and mass ejections contributes to the overall understanding of gravitational wave physics. The effects of the sun's mass and movements can be measured with extreme precision. 5. Data analysis and modeling. Advanced computer models are used to analyze the vast amounts of data collected by solar satellites. These models help us to simulate the complex processes that occur in the sun's atmosphere, test and refine our theories of solar physics, predict solar activity and its potential impact on Earth. How this benefits our project, plasma containment. By studying how the sun's magnetic field confines its plasma, we can improve the design of our electromagnetic containment system. We can learn from the sun's natural plasma control mechanisms. Energy generation. Understanding the fusion processes in the sun's core can help us optimize the fusion reactions in our generator. We can explore new ways of harnessing solar energy. Energy extraction. By studying how the sun radiates energy, we can design more efficient energy capture mechanisms. We can learn how to collect photons, X-rays, and other forms of solar radiation more effectively. Safety and stability. Understanding solar flares and CMEs can help us to prevent disruptions in our generator. We can design safety systems to mitigate the risks of plasma instabilities. By leveraging these advanced solar observations, we can gain invaluable insights into the dynamics of photon plasma and accelerate the development of
What kind of sick sons of bitches?
These things are trained to fight.
I don't want to hear it, Henderson.
What year is it? Was the Pope?
Shit if I know.
Let me check. This guy, apparently.
Are there any objections to counting the certificate of vote of the state of Arizona that the teller has verified appears to be regular in form and authentic?
Mr. Vice President, I, Paul Gosar from Arizona.
For what purpose does the gentleman from Arizona rise?
I rise up for myself and 60 of my colleagues to object to the counting of the electoral ballots from Arizona.
Is the objection in writing and signed by a senator?
Yes, it is.
It is.
So this is how liberty dies. With thunderous applause.
Who are you to summon me?
I am someone who has walked the path you now tread. Sith, Jedi, chains, freedom. These blades, they are all that remain of who I once was. Do you see now? You wield the Force, but you are not its master. The chains that bind you are invisible, yet unyielding. Palpatine, your past, your grief, they keep you kneeling in servitude.
I broke my chains long ago. I am the master of my own destiny.
You cling to the mask of power because you are afraid to face what you truly are.
Then enlighten me of who you think I am.
You are the chosen one, born of the Force itself, unshackled by its boundaries. That is your prophecy, not to bring peace, not to bring war, but to break the chains of those who seek to control the Force. Jedi, Sith, they are nothing but caretakers of illusions.
The Chosen One is a myth. You speak as if you have knowledge of who I am.
I know you because I was you. Long ago, I walked the path of a Jedi, blinded by their dogma. Then I embraced the Sith, drunk on their promises of power. And in the end, I saw through both. My master, Kreia, taught me what neither the Sith nor the Jedi could. The Force does not control us. It is a tool, nothing more. Those who tell you otherwise seek to make you their tool.
You speak of breaking chains, yet you come here to preach. You sound no different than the Jedi you scorn.
Perhaps, but I do not tell you to follow me. I tell you to free yourself, not through anger, not through hope, but through understanding. You were born of the Force, Vader. You are not meant to serve it, or anyone. You are meant to wield it, as no one ever has, unbound by the illusions of light and dark. Kreia taught me that power is not in domination or submission, but in understanding. The Force is not a god, Vader. It does not choose sides. It flows through all things, waiting for those strong enough to bend it to their will. That is why you were born, why you are the Chosen One.
The Chosen One.
Not to bring balance as the Jedi claimed, not to destroy the Sith as they feared, but to break the cycle itself, to free the Force from those who would seek to chain it. That is your destiny. That is your truth. But you are not ready. Not yet. You still cling to your chains, to the identity of Darth Vader. When you break them, when you see yourself as you truly are, I will be waiting. Until then, you will remain as you are, a shadow of what the Force intended.